In the slicer, I selected PETG for the model. The model was assembled as a single piece. To separate it, you simply need to click the Split Model button and then place the parts with their surfaces on the print bed. I made sure to carefully position each part to optimize adhesion and stability during printing. Then, I carefully double-checked the wall and layer settings to ensure everything was set up correctly, including the number of perimeters and infill density, as these factors significantly affect the final strength of the print. After that, I chose variable layer thickness to improve the quality. For areas with threads, I used thinner layers to ensure smooth operation and a precise fit. Additionally, I verified that the nozzle temperature and bed temperature were optimal for PETG, as these settings are critical for avoiding warping or poor layer adhesion. Once everything was ready, I started the print, and everything turned out flawless on the first try. I also print the models one at a time rather than simultaneously, as PETG can sometimes leave stringy residues. This approach helps prevent imperfections and ensures cleaner results. After ensuring everything fit together perfectly and the threads screwed in easily, I carefully removed the brim using a sharp blade, making sure not to damage the edges of the parts. Then, I prepared the remaining elements for assembly. For deburring, I used a tool from Noga, an excellent choice that I highly recommend for its precision and ease of use. It's particularly effective when working with PETG, as it can sometimes leave stubborn burrs around the edges. After deburring, I inspected each piece to ensure smooth surfaces and proper alignment. Next, I used a punch tool to cut a piece of foam, making sure to measure and cut it precisely to fit inside the filter. I made a small cut in the foam, which allowed it to flex and fit snugly within the housing. This step is crucial because the foam acts as the primary filtering material, capturing dust and debris from the filament. Once the foam was in place, I tested it by passing filament through, and it worked perfectly. The filament passed through effortlessly. Then I took a fitting and heated it with a gas torch to loosen the lock. This step requires caution to avoid overheating or damaging the fitting. Once the lock was removed, I inserted the fitting into the new filter. To ensure a tight and secure fit, I lubricated the filter channel with a Teflon-based lubricant. Using a vise, I carefully pressed the lock into place, making sure everything aligned properly. Finally, I chamfered the edge of the tube itself. This small adjustment allows the filament to enter the tube smoothly without catching or jamming, which can significantly improve the overall feeding process. Chamfering is a simple yet effective step that I highly recommend. With everything assembled and tested, the filter was complete and ready for use. This process not only ensures a high-quality filter, but also enhances the reliability of your 3D printing setup, providing cleaner filament and fewer interruptions during printing. As you can see, it's simple, and you'll definitely succeed. In the video description, you'll find all the links to the materials and tools.